Welcome to the DIY Honda Garage channel. This presentation addresses DTC P0710, which signifies an issue with the continuously variable transmission CVT Fluid Temperature Sensor in Honda CRV models from 2017 to 2022. The error indicates that the sensor is failing to relay appropriate fluid temperature readings, creating a possible malfunction in the transmission. The CVT Fluid Temperature Sensor plays a crucial role by monitoring the temperature of the CVT fluid, which is essential for the smooth operation of the transmission. Located within the transmission assembly, this sensor impacts the control module's dynamic adjustments for optimal performance. The reliability of the transmission relies heavily on precise temperature readings, and failure in this component can lead to significant performance issues, including erratic shifting and possible transmission damage. To assist in diagnosing this DTC, we will review a detailed troubleshooting guide outlining steps, symptoms, and possible causes, as referenced from Honda's diagnostic information. The DTC P0710 indicates a problem with the CVT Fluid Temperature Sensor, which measures the temperature of the transmission fluid. This sensor is integral to the operation of the continuously variable transmission, CVT, allowing the transmission control module to adjust shifting patterns based on the fluid's thermal characteristics. The sensor is typically located within the transmission assembly, positioned to accurately gauge the temperature of the CVT fluid flowing past it. By providing this vital data, the sensor helps maintain optimal fluid viscosity and ensure reliable transmission operation. A malfunction in this component can cause the transmission to operate inefficiently, potentially leading to serious issues like overheating or erratic gear shifting. Identifying and resolving issues related to this sensor is essential for maintaining the performance and longevity of the vehicle. The primary cause of DTC P0710 is an electrical circuit problem. This means that the issue is not mechanical in nature, but pertains to the wiring or connections associated with the CVT fluid temperature sensor. Common factors contributing to this problem include poor electrical connections that can lead to inadequate sensor readings. Loose terminals can also create intermittent contact, resulting in unreliable temperature measurements. It's crucial to approach the troubleshooting process systematically to rule out these potential causes, as they can often lead to misleading error codes if not properly addressed. The absence of other faults in the transmission indicates a focused concern on the sensor circuit, which should guide the diagnostic efforts. Symptoms associated with DTC P0710 can manifest as erratic behavior in the transmission, potentially impacting the overall driving experience. One common indication includes delayed or harsh shifting, where the transmission struggles to engage the appropriate gears in a smooth manner. This can be accompanied by poor acceleration, as the vehicle may not respond as expected when the throttle is applied. Additionally, drivers may also notice changes in engine performance, especially under varying load conditions, as the transmission struggles to adjust to the active driving scenarios. Proper identification of these symptoms is essential for accurately diagnosing the underlying issue highlighted by the DTC. Early intervention can prevent further complications, ensuring a safer and more efficient driving experience. For the first step in troubleshooting DTC P0710, begin by turning the vehicle to the on mode. This action activates the vehicle's electronic systems, allowing the Honda Diagnostic System, HDS, to retrieve any stored DTCs. It's essential to check for other pending or confirmed DTCs that may be indicated alongside P0710. Each DTC can provide valuable insights into whether the issue is confined to the CVT fluid temperature sensor, or if it is part of a broader problem affecting the transmission. If additional DTCs are present, Proceed with the troubleshooting process for those specific codes, as they may shed light on interconnected issues. If no other DTCs are found, you can confidently move to Step 2 in the diagnosis. The second step involves verifying the condition of the CVT Fluid Temperature Sensor using the Honda Diagnostic System, HDS. To perform this check, you'll need to measure the voltage output from the sensor under current operating conditions. Specifically, the expected range is between 0.05 to 0.09 volts for low temperature readings, and 4.83 to 4.92 volts for high temperature readings. If the current condition of the sensor falls within the specified range of 0.05 to 0.09 volts, this indicates that the sensor is likely functioning correctly, allowing you to proceed to the next step. Conversely, if the readings show 4.83 to 4.92 volts, it suggests another issue, possibly with connection integrity or circuit integrity, directing you to Step 5. By accurately assessing the sensor's output, you can gauge the health of the transmission fluid temperature monitoring system. In Step 3, begin by turning the vehicle to the off mode to ensure safety while working with the electrical connectors. Next, disconnect the solenoid wire harness A8P connector, which leads to the CVT fluid temperature sensor. After disconnection, turn the vehicle back to the on mode to allow the HDS to read the sensor's response. Check the voltage output of the CVTF temp sensor again. A reading of less than 0.09 volts suggests that the sensor itself is functioning correctly. If this is the case, you can continue to Step 4 to further investigate. However, if the output does not meet this criteria, the sensor has failed, and the next logical step is to replace the solenoid wire harness A. This ensures that you are working with a fully functioning sensor before proceeding with more complex diagnostics. For Step 4, you'll need to start by switching the vehicle to the off mode before conducting any tests. The next crucial step is to jump the SCS service check socket line using the HDS. This action is vital for protecting the powertrain control module, PCM, from potential voltage spikes during the testing procedure. Once this is complete, disconnect the PCM connector C51P to isolate the circuit. You will then check for continuity between the designated test points. Test point 1, which is PCM connector C51P number 37, and test point 2, which is the body ground. If continuity is present, this confirms that there's a short to ground in the transmission fluid temperature sensor TATF wire, necessitating repair. If continuity is absent, it indicates that the TATF wire may be functioning correctly, prompting you to consult authorized service information for further insight, or consider testing with a known good PCM. Proceeding to Step 5, switch the vehicle to the off mode to begin troubleshooting the TATF line effectively. Disconnect the solenoid wire harness A 8P connector, ensuring that you isolate the circuit for accuracy. At this point, you'll create a jumper connection between terminals A, solenoid wire harness A 8P connector number 7, and B, body ground. After making this jumper connection, turn the vehicle back to the on mode and monitor the parameter values of the CVTF temp sensor using the HDS. You're looking for a reading of less than 0.07 volts. If this threshold is met, it indicates a fault in the CVT fluid temperature sensor, warranting replacement of the solenoid wire harness A. However, if the parameters do not match this expectation, the sensor is likely functioning properly, suggesting that an open circuit exists in the SG2 wire, connecting the solenoid wire harness A to the PCM. During Step 6, switch the vehicle to the off mode to ensure safety as you conduct your checks. Carefully remove the previous jumper wire and then create a new jumper connection between terminals A, solenoid wire harness A8P connector number 6, and B, solenoid wire harness A8P connector number 7. Next, turn the vehicle to the on mode once again and utilize the HDS to measure the CVT temp sensor's output voltage. The expected condition is to have a reading of less than 0.07 volts in this configuration. If the sensor outputs this voltage, it confirms a fault, and the next step will be to replace the solenoid wire harness A. Should the voltage readings indicate otherwise, it suggests integrity in the sensor, leading to the need for repairs due to an open in the SG2 wire that runs between the solenoid wire harness A and the PCM. In this final step, begin by switching the vehicle to the off mode to safely conduct electrical testing. Similar to previous checks, jump the SCS line using the HDS and allow for a minute to protect the PCM from possible damage. Disconnect the PCM connector C51P to prepare for a continuity test across the TATF wire. Measure continuity between test point 1, solenoid wire harness A8P connector number 7, and test point 2, PCM connector C number 37. If continuity is established, this indicates that the TATF wire is intact, guiding you to consult any relevant service information or substitute with a known good PCM for further diagnostics. Conversely, the absence of continuity points to a fault and requires the repair of an open circuit in the TATF wire between the solenoid wire harness A and the PCM. After completing all troubleshooting steps for DTC P0710, it is crucial to perform system checks to ensure all repairs are effective and no other DTCs are present. Start by clearing the DTCs using the HDS to reset the vehicle's diagnostic system. Following the reset, conduct a test drive under varied conditions to evaluate the performance of the transmission. Pay particular attention to the transmission's responsiveness and shifting quality, as these will indicate whether the issues have been resolved. Monitoring real-time data during the drive can help verify if the CVT Fluid Temperature Sensor is now functioning as intended. If there are still issues or if any new DTCs appear, revisit your troubleshooting steps to ensure no steps were overlooked and consider possible external influences. To help prevent future occurrences of DTC P0710 and ensure the longevity of the transmission, implement a proactive maintenance schedule. Regular inspection of electrical connectors and terminals is vital, as it helps identify potential corrosion or loose connections before they lead to failures. Additionally, performing periodic fluid changes not only helps maintain proper viscosity, but also allows for the identification of any contaminants that might affect sensor readings. Moreover, routinely checking the integrity of the wiring harness can help prevent shorts and opens in the system, ensuring reliable communication between the sensor and the PCM. Small preventive measures can significantly prolong the life of the transmission system and enhance vehicle reliability. In conclusion, DTC P0710 indicates specific issues with the functioning of the CVT Fluid Temperature Sensor and should be addressed promptly to avoid transmission performance complications. It is crucial to understand that the causes are electrical and not mechanical, emphasizing the need for a thorough and systematic diagnostic approach. Accurate identification of the fault can prevent further damage and ensure the vehicle operates within optimal parameters. Follow the structured troubleshooting steps meticulously, and do not hesitate to perform additional checks or utilize professional diagnostic resources if uncertainties arise. By taking these steps, Honda CRV owners can maintain performance integrity, keeping their vehicles reliable and safe on the road. Please like and subscribe to the channel. See you next time.